Well, greetings, mathletes, and welcome back. We're still going to be looking at constructions today, but we are going to be a little more creative about what we do with them. We've seen some standard constructions. We've seen how to bisect a segment. We've seen how to bisect an angle, copy a segment, and copy an angle. And actually, those four skills are the basis for every single construction. So what we're going to do is take those and see if we can apply them to situations we haven't seen before, or situations we have seen but we haven't really mentioned it directly. All right, so let's go ahead and take a look at our first. All right, so our first example, now we have seen this before when we construct a perpendicular to a line segment, right? But this time I'm going to give us a line. This thing goes on forever. And we want to find a perpendicular line that goes through one particular point. Okay, so, when we look at the construction for a line segment, what happened was we would open up our compass to a certain length. Oops, let's do it so you can see a little better. We'd open up our compass to a particular length, right? As long as it's more than half, you're all right. And then I make a swoop, and then I'll do a swoop from the other side too, if I can line up this point. There we go. Gotta watch out. They do walk. Okay, right? And we have those 2 points. And essentially what we just did, because of the fact that these are circles, each of these are radii, and what I did was I created a rhombus in here. Let's see if you can actually focus on it. I didn't write it dark enough. Right, this is a rhombus, is what this is, if you connect those points. And a rhombus has the property that that the diagonals bisect each other. And so that's essentially what we're doing here when we find this bisection. Let's see if I can find this bisection now of all these others. Right, so now I have a perpendicular bisector. What we want to do is find one that goes through this point. So I'm looking for a perpendicular that comes straight down through here. Now you can eye it in, but that's not how we want to do things. So what we need to do is create a segment, right? We don't have a segment, but we can carve one out. And we need to carve one out so that this point up here is the same distance from both points. Oh, you can't see that. Okay, let's try it again. So I want to measure, let's see, how do I want to write that? So this point over here is on the point I want to make a parallel line through. And what I'm going to do is I'm going to mark off a segment here, and it will be equidistant from both end points of the segment will be equidistant from this point that I want to make parallel. Okay, so let me go ahead and mark that segment off. Okay, so now what we just did was we created a segment, and we know the perpendicular will go through this point. So all I need to do is find the point on the other side that makes it a perpendicular. And so now that I have a segment, I can just bisect this thing. And what I'm going to do is I'm going to keep this distance that I just marked off, and I'm going to mark it this way also. And then I'm going to come from this point here and mark this distance once again. Right? And this point right here is my other point. And so now I can draw my perpendicular through that point. Right? Notice at the same time I also kind of created a rhombus. It's there, I just didn't draw in the lines. Right? If I connect these in, I have a rhombus, and I'm very specifically using the fact that rhombi have their diagonals are perpendicular bisectors of each other. As a matter of fact, their diagonals also bisect the angles. Right? When we copy an angle or bisect an angle, we're actually using a rhombus again. Okay, so that's the construction if you want it at a point. So you start off by, you center your compass here, and you mark off 2 points to be your line segment. Then you just use the regular construction for a perpendicular bisector, and it should go through this point, provided that you did your construction carefully. I think I'm going to make the next picture a little bit bigger. Okay, so this next one, we have seen the construction for a parallel line, but I want to review it one more time because sometimes it's not, I did it in passing before, so I want to make sure we understand this. So if you have a line and you want to make a line that's parallel to it, right? Basically what we do is we copy angles. So we're going to draw an angle, and you notice that's any old angle I wanted. What I'm going to do is I'm going to take this angle and I'm going to copy it up here at some point. I'm just going to pick a point and I'm going to copy that angle up here. And then by corresponding angles, the line that's formed should be parallel. So let's go ahead and start by copying the angle. Actually, I'm going to need longer lines for this. I can already tell. Let's just extend that to the edge of the page. Okay. Okay, so I'm going to start out by making my first arc. Right? Okay. And then I'm going to come up to the point I want to make this at. I'm going to make the same arc again. Okay. And then I'm going to measure this arc in a direct linear measurement. Let's see if I can do this so that you can see it. Okay, so I'm measuring that, and I'm going to mark it from this end. Maybe you want to think about it as measuring it from this side, right? So you can see where that marks. Now we just need to mark the same thing here. And this point right there should be a parallel line. And basically what we did is to force them to be parallel lines, we copied the angle, and then we used the corresponding angle theorem that says if you have two lines and a transversal, those lines are parallel if and only if corresponding angles are congruent. And so we basically use that theorem backwards, right? But notice that we also had a point to pick, right? So if we wanted to do this way, if we had a line and a point, and that line is not completely straight, I think my compass or my straight edge moved, and we want to make sure that the line is parallel at that point. What we do is we go ahead and just make sure that we draw the angle through that point, and then we copy the angle at the point. So we want this angle copied up here. This is what we want. So we're going to do the exact same thing we did before. I'm going to measure off here. Hey, we're going to try to measure it off here. Sorry, to make sure you guys can see it, I have to kind of hold the compass at an unnatural angle. So, okay, so we'll make our second stroke here. And then we need to measure this thing back the other direction. So we'll go ahead and close that up. A little bit bigger. There we go. Not quite. There we go. My compass is getting dull. Okay, so we got a compass stroke there, and we just need to draw it in. Okay, so these are actually more specific skills. Well, we won't count that last part. I flipped off the end there. These are more specific skills, but they're more useful because most of the time you want a parallel line that goes through a particular point or a perpendicular line that goes through a particular point. So this is a way to do both of those things. Okay, so basically with the parallel lines, we are copying an angle. With perpendicular lines, you are bisecting a segment, but you have to make the segment first. Okay, so those are our first two things there. Okay. Yeah, let me go ahead and get this off here. Okay, so this next one, we're actually going to have to get a little creative. It's not a standard construction. It's one where you're asked to be a little bit creative about things. So I'm going to start with a line segment. Okay, so this is a given. You're given a side length, and it's actually not a side length. So AB is a diagonal of a square. Okay, so AB is the diagonal of a square. Construct the square. Right? A diagonal is enough to determine a square. So before you get started on something like this, because there's no standard, well, there are standard ways to do these, but it's not, it's a creative construction. So let's go ahead and take a look. I'm just going to do a little sketch here of a square and take a look at what the diagonals do, right? Okay, so what do we know about the diagonals, right? Let's see here. Well, a square, all the sides are equal, aren't they? Right? Which means that it is a rhombus. And a rhombus has the property that the diagonals bisect each other. Okay, a square has the property that the diagonals are identical, right? So we need to take that information, the fact that this line and this line are the same length and meet at a right angle, and use that to form a square. Okay, so you have to kind of go through inventory of what you know about the figures. So here's how I'm going to start. I'm going to start by drawing a diagonal. I'm going to draw it horizontally, even though it's a diagonal. And what we're going to do is measure off a length that's the same as AB. So I need a point to start with. Let's start here. And we'll just go ahead and measure this off. Make sure that that goes through at the right place. Sometimes it's a good idea just to give it a little stroke to see where it's going to draw the line, because sometimes it's not as accurate as you think. Yeah, okay, so now we'll just do the same stroke here. Okay, so now we have a side length AB. Okay, we know these are two opposite corners of a square, so it's going to do something, you know, like this. I'm trying to do that very, very lightly. So if we're going to construct the other diagonal, right, the other diagonal is what would finish off giving us the square. So I need to construct a perpendicular bisector here, right, so that I have a perpendicular line. I have the endpoints, I can do a perpendicular bisector. So let's go ahead and do that. There we go. And we just need to connect those dots now. And overextend your line because you're going to be cutting it down. Okay, so now we have the other diagonal, but we don't have it cut down to the size we want. That's a problem. Well, it is and it isn't. If you look at the square, if these are all bisected, all of these pieces are the same also. So that means if I center my compass here and measure this length, right, this is, I can make my compass radius this, and it'll end up carving off that part on all of those diagonals. So I have the length that it's supposed to be from its center. I just need to close it up a little bit so that we're marking in the correct place. And now I can go ahead, see if I can do this without moving my compass. This is an improper way to use a compass, by the way. I'm just trying to make sure you guys can see it. Right? Basically what you're doing is this. So now what you just did is create this situation where this is equal to this is equal to this is equal to this. They form at a right angle. And so all you have to do from here is connect the dots. Right? And that should be a square. You notice we didn't construct right angles at the corners at all. We got to this completely indirectly. Which it's one of the reasons I really like geometry. Well, now it fades back in. There we go. You can see all the stuff there. And this point right here, if you turn it so that it's so that it one side is more parallel with the bottom, you can see that this is now a square, and this AB is its diagonals, right? You can say that this is AB if you want. Oop, B. Let's try the second letter in the alphabet. Right? So that's a construction given an indirect measurement of the shape that you're trying to create. So let's just kind of review the steps that we took again. So I started out by copying segment AB, right? And I looked at it and I said, okay, so that's a diagonal. So I drew a picture, right, just to play around with it. And I just wanted to see what the properties of the diagonals are. So I had one diagonal, and I could see from the drawing of the square that these diagonals meet at a right angle, which means that I have to have a perpendicular bisector, and that they are all these, the way they bisect each other, they actually bisect the segments also, which means that the corners of the square are equidistant from the crossing point. And so I used a circle to mark off equidistant segments. And then from there, I just connected the dots, right? So you have to use your wits a little bit with a lot of these constructions. Okay, so let's go ahead and take a look at the next couple here. All right. Okay, so the next part of this has to do with specific angle constructions. These are some examples I've put together so you kind of have an idea of how to do these things. Keep in mind that you have additive and subtractive properties for angles too when you construct. So, for example, if you have this angle, and let's just call this one alpha, and I have a second angle I've constructed here, and this one is beta, then this entire angle is alpha plus beta, right? So the whole thing in general, when we look at it, is both angles together, and that totally makes sense. And you can do the same thing with subtractive, right? If you have an angle, and we'll call this angle alpha, and I go ahead and construct beta here, then this angle right here is alpha minus beta, right? So there's ways you can do these things. And then the other thing you want to remember is that you also have bisections to deal with, or to use. I shouldn't say to deal with, to utilize. So let's go through and just construct these angles. There's actually lots of ways to do each one of them, so it would be quite interesting if you could come up with more than one way to do it as well. But I'm just going to go through one way. So 90-degree angle. Well, that's a right angle, and we know exactly how to make a right angle. We just finished doing it, right? So for 90 degrees, if I want to construct a 90-degree angle, right? All I really have to do is bisect a segment. Once I do that, I'm in the clear. Oop, let's try this again here. Let's open that up just a hair more. Right? So I've just, by creating this segment, or by bisecting this segment with a perpendicular, I've just created a 90-degree angle, right? So this is a 90-degree angle. We've constructed it to be so. Okay, so now then there's 45-degree angle. Well, just stop and think about it a little bit, probably it's already come to your mind that if you bisect a 90-degree angle, you get a 45-degree angle. And that's exactly the case. So what we're going to do to create 45, right, here's my 90. I'm just going to mark it so we know where it is. I'm going to bisect this side to make a 45. So make sure, well, we'll do it that way. Hey, let's make sure that didn't jump too soon. It did. Okay, then we'll go ahead and open it to there. And then the other side here, we'll open it to there. Sorry, my construction got, Let's try this one more time. There we go. Right, and once we've bisected that, we have a 45. Right, here's my 45-degree angle. Right, so you can get a 45 just by bisecting a 90. And actually, you can get a lot of stuff. If you keep bisecting, you get 22 and a half, and then 11.25, and you can just keep going down from there. But bisections are a good tool, right, to start with. So we got the first two checked off. Now this idea of a 60-degree angle, right? And so we want to think about where we've seen a 60-degree angle come up in a construction of some sort. And really where they come up naturally is if you create an equilateral triangle, right? If all these sides are the same, that means all the angles are the same. And if all the angles add up to 180 degrees and they're all the same, I just divide it by the number of angles and I get 60. Right? So an equilateral triangle has a 60-degree angle. So if we can construct an equilateral triangle, we can make a 60-degree angle. Okay? Now, this actually will start to look a little bit like our socially distanced circles. Right? So keep in mind that what happens when you make a circle is you are marking all the points that are the same distance from a center. Right? That's essentially what you're doing. You have your center there, and I'm going to mark it a little darker so you can see it. And then we just mark out all the points that are the same distance away. Okay, so I haven't moved the compass yet. So if I measure it back the other way, that means I'm marking the same distance here. Now keep in mind, I said I hadn't changed the compass stroke, right? I haven't changed the width of the compass. So this circle was centered here. This circle was centered here. Now, let's just reason our way through this. So that means that this distance right here is a radius, right? That's a radius of one circle. But since this starts at the center and ends here, this is also a radius, right? That's also a radius. And from here to here is the same distance as from here to here, because those two belong to the same circle. So I have just now created an equilateral triangle, which means that all of the angles are the same, and this is your 60-degree angle, right? This is your 60 degrees. My drawings are getting a little small, I think. Let me go ahead and blow them up a little bigger here. Okay, so that's my 60-degree angle. I'm actually ignoring the triangle now because all I wanted was the angle. Okay, so now the question is, can we create a 30-degree angle? And I suppose that you probably correctly deduced that all we need to do is bisect this angle, right? Now keep in mind, I already have the first compass stroke here that marked off this point and this point. So all I have to do now is measure points out here. And that's what I'm going to do. I already have two equidistant points, so I'm going to mark them one more time. And that gives me my bisection. And if you don't see how I did that, go ahead and walk through the full bisection process, and you'll see why I was able to reuse that particular point, these two particular points. But yeah, this should be 30 degrees now because it's half of 60. Now, the 75-degree angle, right? We have no way of constructing 150 degrees and bisecting it. That would actually be a little weird. But, there really are a number of ways to get at this. But I think the easiest way is going to be this additive way. Because you notice what we have here. I have a 45-degree angle and I have a 30-degree angle. And if I add them together, I get a 75-degree angle. So that's what I'm going to do. I'm going to start, and I'll do it down here, by copying the 30-degree angle. Okay, so let's go ahead and do that. We'll copy that 30-degree angle. It even makes that sound. Right? And then, right, we want to measure to where it crosses the arc. So we'll do the same thing here. Okay, so now we have a 30-degree angle. I feel like I'm running out of room here. There's never enough room for math. I'll tell you what. Okay, so now I have 30 degrees. And so the next goal would be to copy the 45-degree on top of that. So that's what we're going to do next. We're going to copy the 45-degree angle. So let me open this thing back up. Probably should have. Let's extend this a little bit more so I can get that crossing. There we go. Okay, so now we're going to do this. And you notice I'm doing it to up here. Let's make sure I did that right because that slipped. Okay, so now I'm looking for the distance from this second point here. So now I just need to measure from here to here. Okay, so I measured it out, and I just need to cross it on here. There we go. There. Right, and so this one is 45, which means that the total here is 75 degrees. Right, so your full arc is 75 degrees because this one's 30 and this one's 45. Incidentally, once you have 75, you can make 90 because if you erect a perpendicular here, right, which you can do, this piece right here would be 15 degrees if you threw in a right angle. So you can actually get a lot of these things all at the same time. It's pretty remarkable, really. Okay, so that was a whole lot of stuff. Really, it's about being creative with what tools you have. That's really what mathematics is all about. I know a lot of the time it's taught, this is how you do these things, but that's because those are the basic things that everybody uses. It's just learning how to use your fundamental tools. A lot of the time you end up using those tools in a different way. So in any case, let's go ahead and look at the next set of things here. So let me go ahead and get this out of the way here. Okay, so the next thing I want to look at is constructing a triangle from angle side angle. Okay, so here's what I'm going to do. I'm going to give you a side, and I'm going to give you two angles, and then we'll try to figure out how to put these things together. So first off, here's my side, right? So there's one side length, and then we're going to do two angles. Oh, yeah, I should do it this way. So here's one angle. I'm running out of, let's turn this around. There we go. Okay, so there's one angle, and let's do it here. Here's the other. Okay, so we have to make a triangle out of this. Now, keep in mind it's angle, side, angle. So let's look at what that means for how to put these things together. Okay, so if I have a triangle, if I identify things with angle, side, angle, it would be an angle, a side, and an angle. So that means that what we have to do is this side, this is this side, and then these two angles are the angles on the outside of those. So this is an angle, side, angle construction. So what our goal is to construct a triangle that has these properties. So um, actually, you know what? Right now would be a good time for you to attempt to do this on your own. It's not crazy, and I think with a little poking around, you could probably work it out. So um, let's go ahead and pause this here, and we'll see how you do with it, and then come back and see if your construction matches mine. Okay, so go ahead and pause it here. Okay, so I'm going to assume you've paused this. All right. So let's take a look. So first off, I think probably most people saw that copying the segment would be a good way to start. So I'm going to actually do this down here where we can have more room and you can see what I'm doing. So let's pick a point here, and then I'll just measure off this segment. Oh yeah, I forgot I have these things. Okay, so just do the same here. Okay, so now we have our points, right? So there's our segment. Now, it's angle, side, angle. That means that these two angles attach here and here. So all we have to do is draw them in, and then where they intersect is going to determine the rest of the triangle. So let's go ahead and copy these angles. So let's go ahead and start here. So copy this one here. And then you have to sing it when you're thinking. Then, oops, not there yet. Okay. Nope. Well, this is a hard one to dial in. There we go. Okay, so here's our first angle. Go ahead and overextend the angle too, because you don't know where it ends, so that gives you an opportunity to cut it off. So go ahead and draw this. And now all we need to do is copy this angle here, and we'll have the triangle determined. So let's go ahead and do this. And then just measure across here. Oh, a little smaller. There we go. There we go. And that ends up being our other point. And we'll just draw it in. And now we have a triangle, right? This angle matches this angle. This angle matches this angle. And this side matches this side. And so we've done angle, side, angle, right? We've just constructed this triangle. It's actually really cool. I find it fascinating that you can just take little pieces of things and build an entire complete structure out of it just with sparse pieces of information. It's one of the things I've always loved about math is that there's so much indirect goodness. So anyways, before I start spouting about how much I love geometry and math, let's go ahead and look at the next example here. Okay, so this next construction is going to be an angle, angle, side construction. Okay, so you have two angles here. You have a side. Okay, let's make sure we understand where these angles and sides go because it's real easy to accidentally do an angle, side, angle when you're doing this. So I'm just going to sketch a triangle real quick. And the arrangement here, if I have this side and I have one angle that's attached to it, but the other angle is not attached to it. So we don't know this side or this side. And the problem ends up being is where to put this angle. And you have to be kind of creative about it because you don't know how far out to go to do it. Okay, so we're going to actually have to get a little bit creative about this one. This is actually a fairly tough construction. I would be really impressed if you guys, if one of you got it. I'm sure one of you could, by the way. I'm not saying that this is an impossible problem. You have to poke around at it a little bit longer to figure it out. So I would like you to at least try it, see what you can get. At the very least, identify why it's difficult, because that's actually one of the biggest issues with problem solving is being able to understand what your hump is, what the thing is you're trying to get past, right? What your obstacle is. That's the word I was looking for. Once you figure out how to overcome that obstacle, the method you use to overcome it becomes a tool in later problem solving, right? And this is how math builds slowly. You figure out how to do one thing, and suddenly you realize that applies to a whole bunch of other things. So let's go ahead and get started. Actually, pause, of course, and then we'll get started. Go ahead and pause it here. Okay, now we can get started. So probably the easiest thing to do would be to start with the line segment. That's typically where you start with these triangle constructions. You actually cannot do a full triangle construction. You can construct one, but you can't copy a triangle if you don't know any of the side lengths. Probably should have done that lower. Let's do it down here. That's just a why not type thing. I'm going to do this down here. Okay, so let's start by copying the segment. All right, we're getting pretty close there. Let's see. So let's pin that and see if we got it. Notice how I'm making the stroke through the point. I want to make sure that I'm actually measuring the thing I'm measuring. That's why I do that. Okay, so I already have a point here. And we'll go ahead and mark that off. Okay, so we can see from the picture that one of the angles goes here, right? So we're using the picture as our map. One of the angles goes right here. So I'm just going to use this one, and we're going to copy this angle and put it here. It's the second angle that starts giving people fits, generally. Come on now, you can do this. Okay, there we go. So there's our first stroke. And let's see if we can mark that down right. There we go. Second stroke. And then we'll get our first angle here. I want to make sure this goes far enough because you never know. All right. So now, how do we get that other piece? How do we figure out where to put that other angle? Because we can see it goes up top here somewhere, but I need to do it so that it goes through this point, right? That's my problem. So we're going to use that parallel line thing. We're actually just going to put that angle wherever we want. We're going to start that way. So I'm going to start by copying this angle. Right, and I have to copy it. I'm just going to copy it up here. All right, and you notice I just picked a random point to copy it at. I chose to try to make sure it was going to be bigger. The triangle is going to be bigger than the actual triangle, as you can see. Right, if I draw this in, wait a minute, where did I just do that? Let me try that again. I didn't mark the point. Ay, ay, ay. It should be up here. Damn it. I screwed it up. Let's do this again. Oh, it's this one. I lost track of what I was doing. Okay, so let's make sure I know where the center of this circle is. That's where I'm having problems. I changed the center of the circle. Okay. Okay, so that should be it. Yeah, there we go. So it's that. I measured that, and then I measured this, right? From here. Yeah, okay, good. And here's the center of that circle is right there. And so I just need, well, that's actually pretty close. Damn it. I actually tried to overshoot it. Oh my God. It's going right through the point. Okay, so that was the biggest luck out I have ever seen. I've never done that before. I'm going to start this thing over real quick because I can't believe that, because that never happens. You never actually line it up the first time. You actually have to adjust after you make the first thing. Um, well, okay. Let's try this one more time. Okay, so I just went ahead and did everything over again up to the finishing that last angle. Okay, so I'm going to do this again, only I'm going to make it a little more realistic. I still can't believe that thing worked out perfectly, and that was completely by accident. You always want to show the screw ups with when you're working this stuff out, and well, quite honestly, not screwing up turned out to be the biggest screw up. Okay, so let's go ahead and copy this angle again. Right, we need to copy this second angle onto that point. And so we're going to measure this out. And see, I'm still trying to reuse the same stuff we did before. Okay, so we want to mark that. Okay, and then we're just going to measure this distance here. That's good. We'll measure that from here. And so now we have this. There we go. This is more typical of what happens. So it's clearly not the right triangle because we need this to go through here, right? This is the right angle, but now this side is the wrong size. We need to scale it down to here. Well, if you remember, one of the first constructions we did today was finding a parallel line through a point. So what we're going to do is we're going to copy this angle right here is what we're going to do, and that'll make a parallel line that intersects, and it'll make this side correct, right? So that's what we're going to do. We need to measure this angle and copy it. So you notice we're using the third angle even though we weren't given it. Right, so I'll make that mark here now. And then I just need to measure across here. And then measure it here. And this point and this point should line up now. You can see how meticulous this is. And if your compass skips around a lot, you start getting a lot of errant marks that start confusing you. But yeah, now from here to here to here, this angle matches this angle. This angle matches this angle. Oops, let's put 2 marks so we can see it. And this side matches this side. And so we have angle, side, angle. But you notice what we had to do. We had to make an angle that, we had to make a side that was too big first, and then cut it down and make a parallel line, right? So I made I made a big triangle, and then I cut it down to the size it was supposed to be, right? And that's actually a fairly difficult construction because you always expect constructions to be a little bit more direct. This one, you actually basically make a guess and then adjust your guess, right? honestly, I'm still tripping out on the fact that I actually guessed right the first time on the first example. It would have gone through and made exactly the right triangle, and then it would have confused you all because it wouldn't have worked for you guys when you tried to do it. So, in any case, that's the last of what I wanted to cover today. So, yeah, there we go. Let's go ahead and close that up. Until next time, keep your pencils and your wits sharp, and your compass. Keep your compass sharp and your edge straight.